Hi and welcome to this episode of Talk to the Experts. My name's Alex and today we have Mark Bonner with us. To kick us off, Mark, please can you just give us a bit of information about yourself, what you do here at ASAF?
Okay, so my background is in polymer physics. Went to the University of Leeds, got a physics degree, stayed on, did a PhD in polymer physics. Spent the next 20 years there in the IRC in polymer science and technology, essentially doing processing and simulation. And then moved here to become the material science expert of ASAF.
So day to day in the life of Mark Bonner here at ASAF for how many years?
10 years now.
10 years, cracking. What is that day-to-day process? What are you looking at? Is it sort of things what are happening today, things which are moving into the future?
We've got both going on. I'm involved in any new project at the start with help with material selection with the designers. We're also looking further down the line now. We're starting to really develop materials in a big way. We've got some collaborations going with the university, looking at entirely new materials. We've got some collaborations going with machine developers, bringing new techniques into the company as well.
I think what you touched upon there, working with the universities and external companies and all the research we do, that adds to the more than a yellow barrier, what we're looking at today. So from an engineering standpoint, what is it from your perspective? What does it mean when we say more than a yellow barrier?
More than a yellow barrier, well, we already use advanced materials. We already use materials from the automotive sector, which are specifically designed to be high impact, to absorb a lot of energy, to not fracture, to be able to cope with a huge temperature range. And we're looking at extending that and really pushing the envelope.
Yeah. I think one of the main things that sort of take it back to the beginning of workplace health and safety, majority of our customers and workplaces relied on steel barriers. That was the common thing to have. We still see it today. But what is the sort of benefit in steel, and where do we see those major issues are when it does start to move into the industrial safety barrier?
Okay, so your major benefit of steel, it is very strong. Mm-hmm. It's very stiff and very strong. And that's also its downside. Yeah. If you hit a steel barrier, you're very likely to rip it out of the floor. Mm-hmm. It's so stiff, it won't dissipate any energy. It won't spread the energy over its entire surface. So you just end up with it coming out of the ground and ripping the fixings out. Whereas with our barriers, they're designed specifically to spread that energy over a larger area. We don't damage the floor. Yeah. Yes, you might have to replace our barrier. No, you don't have to replace the concrete. Yeah. You're not losing space.
Mm-hmm. And do you think that reflects as well onto more low impacts as well? So we're not talking about the big full whack onto the barrier, but the smaller impacts multiple times?
Yes, definitely. I mean, the trouble with steel is at the moment you go over its yield strength, it's not going to recover. It's going to look dented. I mean, you look at your car, you have a small dent in it, you can see it. Yeah. Also, as you accumulate those dents over time, you're likely to get sharp edges. The paint's going to come off. You're going to get rust, you're going to get corrosion. None of that happens with our barriers.
Yeah, so when we're talking about polymer, that full ability to absorb, dissipate the energy, and ultimately change the outcome of how that performs. So when we look at ASAF as a whole, what are the benefits of a polymer barrier? We've looked at steel where the plus sides can be, but also the negatives. When we look at our ASAF polymer barrier, what really sets it apart?
Especially with the new Gen 4 systems, we're looking at those repeated impacts, those little everyday knocks. Okay, so the new Gen 4 systems, they've been specifically designed with polymers that are going to recover. Mm-hmm. Yeah, give them an hour, you won't know they've been hit. Give them a quick rub, you won't know they've been hit. They also provide you, at the top end of the range, they give you more energy dissipation. Mm-hmm. So again, we're spreading that energy load. I mean, it's not only good for your concrete, it's good for your drivers, it's good for your people. If you hit a solid steel barrier, your forklift driver is going to know about it. You're potentially going to have people off work with whiplash. You hit one of our barriers, and I know because I've done it, it feels just like your forklift motor's gone wrong and you stop. So there's benefits to your people, to your property.
Yeah, so when we talk about that return on investment as well, it's not only the barrier, which we're talking about, the replacement of the concrete. What else is there what we're looking to protect in a facility? What are we trying to achieve with the polymer barrier?
We're trying to get the heuristic, I think that's the right word, the overall, the global protection of everything and the benefit to the business. So yeah, you're protecting the people. You're protecting the people on the far side of it from the forklift. You're protecting the forklift driver. He's not going to get injured if he does have an accident. You're protecting your property. The barrier is going to stop the vehicle hitting anything bad. You're protecting your investment. You're protecting your space. One of the big things we've had in the past, and one of the things that's really sold our barrier when we've been doing site demonstrations, is the fact you can hit our barrier multiple times. And yes, you're going to have to replace it after a while, but you don't lose the space. We had one customer came in who was complaining that every time his steel barrier got hit, he had to move it out a foot. So he had less space in his warehouse after 2 years.
Yeah.
So
yeah, completely makes sense. That kind of brings me on to our next point in and around stronger is better. I think that's always a mindset for a lot of people. They always think the bigger, the stronger it's going to help them. From an engineering perspective, what would you say about that when we look at the polymer market?
Stronger is definitely not better. The stronger, the stiffer something is, often the less energy it can actually absorb. What you want is something that deforms. If it deforms, it can absorb, dissipate a lot of energy, a lot more energy. It can be very stiff steel, very stiff, but also it's going to break at like 6-7% extension. The polymer we use in our barrier rails, okay, it yields at 6 to 7% extension, but then it'll go on. You can get over 100% extension in it. That's absorbing energy all the time, and it's not breaking.
Yeah.
And the more energy you can absorb, the less is going to go into your property.
So technically, the stronger, the less safe. Especially when looking at the perspective of somebody driving that forklift as well.
Yes, in a lot of ways, yes.
Yeah. So in practical terms, how does ASAF's engineered polymer behave differently to steel during an impact?
It moves, it deforms. Steel won't do that. Steel will crease, and once it creases, that's it. All the load's going into the fixings. Our barrier spreads the load. As it extends, it's stretching. We've got the coupling system, which is designed to take up load. We've got the pins, we've got the post. Every single part of our barrier is doing something to lower the load that's going into the concrete.
Yeah. I think one of the important points you mentioned there was that coupling system. Now, we've compared ASAF barrier to steel. Now, we've done a lot of research, me and yourself, quite often on the rest of the polymer market. How does that coupling really drive ASAF into that different echelon of polymer safety barriers?
As far as I'm aware, and you can correct me if I'm wrong on this, we are the only people who use a coupling system. Other people just slide rails over smaller rails. We did that on our Generation 1 system.
Yeah.
That has a downside that sooner or later you're going to get a certain amount of extension in that rail as it deforms. It's just going to pull off that. Our coupling system is designed not to allow the rail to do that. So we can put a lot more into our rail than our followers can.
Yeah. And I think you mentioned the generations there as well. In your 10 years, how much has that coupling developed in that time?
Enormously. When I started, a double traffic would only do about 10,000 joules. Now on the Gen 4 system, we're 20,500. So we've doubled the amount of energy that our barriers can withstand.
Yeah, and that's all looking at different manufacturing processes, different materials, and how that barrier works, the system.
Definitely. It's all the development that's happened over the years.
Perfect. So when we look at the ASAF difference, quite a lot of people will see our barriers in sites, black and yellow posts. From an engineering perspective, what are the key design principles that sort of differentiate ASAF from anything else on the market?
Number one, we do have that coupling system, and that coupling system does a lot of work for us. Our followers don't have that.
Yeah.
Number two, we specify our materials to do a job. A lot of our followers specify their materials based on a price. So I am not going to say we are cheap.
Yeah.
We do a job. Okay. And we will do the job repeatedly. A lot of our competitors won't.
Yeah.
And we do as much as we can to make sure that our barrier, and a case in point, we very recently had a guy from TUV Nord come in. And when he comes in, he goes over everything with a fine-tooth comb. He makes sure all our equipment is calibrated. He double-checks how we do a test. He makes us weigh everything in front of him. Yeah. We have to take a barrier apart and reassemble it in front of him. So he measures every component to make sure it's as we say on the drawing. And then, after all that, we hit it in front of him. He calculates the energy we've hit it independently, and then says, yes, you hit it at 20,500 joules, I'll give you a certificate. Okay. A lot of our competitors don't do that.
Yeah. Yeah, then obviously we've got that huge benefit of being on site with a customer, with that certificate, giving full clarity of our whole performance of our product and how it can help them in the long run. So I'm just going to ask you to put on your high-vis and your safety boots and imagine you were walking around a site. What would be the first red flag if you were going into a site which had no ASAF barrier? what red flags would you be looking at in and around sort of pedestrian walkways and heavy traffic?
To be completely honest, if I'm doing that, it's going to be in the car park.
Okay.
If they've got vehicle movements in the car park, is there any kind of pedestrian segregation?
Yep.
If there isn't, why not? Okay. That's a red flag. If they're not even thinking about people walking onto site, what are they going to do when you get inside? When you get inside, again, if there are forklift areas, it's a pedestrian segregation from that. Are there gates where crossing points? Are crossing points marked?
Yeah.
All that kind of thing. Small little things, but they all add up to be a risk.
Yeah, definitely. And just to close things up, if listeners can take one thing from today regarding more than a yellow barrier, in what terms and what does it mean to you? What would be the final thing you would say to people more than a yellow barrier in, feel free, engineering terms?
I'm going to say it's engineering terms, but from the ACE's perspective, it's the amount of development work we do.
Yeah.
We're releasing Gen 4 now. That's been in development for 5 years. All the way from proof of concept through to now. The amount of testing we've done that to get to that point is enormous.
Yeah.
We've essentially built the test facility around it. So when we release that product to the market, we can stand behind it and say, we've tested it. We've done hundreds of barriers, hundreds of impacts. And we know that when we tell you it's going to do this, we've tested it to do that.
Full trust.
So yeah, full trust. Our barrier, if we say that our yellow barrier is going to do this, it will do it. I wouldn't say that about some of our followers.
So a final point, Mark, before you leave us today, what's the future in terms of material science, in terms of the new projects which are upcoming without giving too much away?
So we've just introduced our new generation of barrier with the monoplex products in it. That's a huge step forward in material science and engineering for us. And there are further advances like that coming down the line that I unfortunately can't talk about at the moment.
No problem in that. That's all for today. Thank you for joining us, and catch us next time on Talk to the Expert.